All right. I think I think part of the problem with these is that you get confused when there's no place that it equals zero. Am I right? So, but remember what maxes and mins mean, right? It doesn't necessarily. Let me do it first. So 3/5 x to the negative 2/5, which puts that in the bottom, right? So I've got an x in the bottom. Well, that's never going to equal 0 because if I have a 3 up top, it doesn't matter here. Let's see. The only way to get 0 is if the top is 0 is what I'm getting to. So it's never going to equal 0. But what I do have to consider are the places where it's undefined. And here is why I have to think about that. Because with something like, oh, there shouldn't. You're right. Thank you, Logan. Um, we may have done this one in class. If we did, I apologize. But since I'm already in this deep, let me just address this real quick because I've heard several questions about this kind of problem. Even though the derivative doesn't equal 0 here, what's happening right here? Oh my gosh, you are kidding me.
This time, all first-time freshmen are scheduled to go on the WTC field trip this morning. Please report to the West Blue at this time. This will be first-time freshmen, last name A through Green. Again, these are first-time freshmen. Teachers, you can refer to the list that was sent to you from Caitlin Matthews. And again, students, while you're on the trip, make sure you're on your best behavior representing Camden High School. Have a good day.
Logan, if you need to. All right, so look at this point right here, right? What is happening there? It's a cusp, right? It's a cusp. So it's not differentiable. That's right. It's not differentiable, but it's still a minimum value. Does everybody see that? Yeah. This is a case in point of why I have to include where this is undefined. Because this would be where the bottom is, right? So so x equals 0 is one of those points that I need to test. Even though it doesn't make the equation equal 0, it makes it undefined, so I have to test it. Does that make sense? It makes the derivative undefined because it's not differentiable there. Are y'all following me? Logan, you're so full of crap.
Did you see your class on Friday?
It was awful. It was awful. Okay.
Sorry, it was my fault.
Okay.
Yeah, what time got rid of
Okay. All right, look. Between -2 and 0, what is the sign of the derivative? I hear both. If I plug -1 in here, I've got an odd root. It's negative.
Oh, look at there. That's what we said.
Okay. No. Okay, but it's the difference in this and this. If you take out your calculator and you do -1 raised to the 2 divided by 5, what do you get? Yeah, but if you multiply by a positive, what do you get? Because, all right, so the odd root definitely keeps me negative, right? You're right. Because what I'm doing is I'm square. I'm thinking. All right. The squaring. Forget I said all this. I'm thinking like this. All right. So here's what's happening. Listen. I'm squaring down here, so everything's going to be positive every time. I don't know what I'm thinking.
You guys have to take a while.
We told you that.
Sorry. I am.
They're both positive.
They're both positive. Because when you square any number, what happens? Top number is what the exponent is. So no matter what I do, I'm squaring it, I'm forcing it positive. Sorry.
I always thought they
Hey, wait.
I think I even talked about this one. Was it with you yesterday? No.
we already did.
Did we? Okay. Yeah, whatever.
That is our graph up there with the little V thing. How is it going down and then up?
I was just saying, for instance, it could look like that. That's not necessarily what this graph looks like. I was just saying rational exponents, they could look like that. Okay, so here we go. So where are my possible extreme points? I already know where my minimum is, right? Do I even need to test 0? No, because if I'm steady increasing, it doesn't matter. That just means I stopped there for a second, but I kept going in the same direction. All right, so f of -2 would give me what? What is it? What is that rounded or is that? But it does matter. Take it 3 places. 5.51. And I'm being particular about that because if you don't take it out 3 decimal places rounded on AP exam, then what they will do is not give you your answer point.
Well, you know what kept them?
I know. It's just always 3 decimal places. Yeah. All right. Now the other thing you could do if you knew what it equaled is you could just put -2 to the 3/5. You could leave it like that. But if you're gonna do a decimal, it has to be to 3 decimal places. I mean, obviously not if it's 0, but all right. What about f of 3? What do you get?
Oh, wow.
All right. So I have a maximum. Is it absolute or relative? That's an absolute, y'all. I'm on a closed interval, though.
All of these are closed.
So they're all, and by EVT, that says there's an absolute max and an absolute maximum. Yeah. So it's a max of 1.933 at x equals 3. There's a min of -1.516 at x equals -2.
Are you Shankar?
Party at Miss McGee's house. After party at Miss McGee's.
It won't be the kind of party y'all are thinking, but I'll cook y'all some breakfast or something.
Oh, wow.
What kind of person?
I told you that would be cool. I told her she should invite some people and have breakfast.
Can we come up?
Like after the dance. Why does it keep doing that?
Hold on. Breakfast like the night.
Okay. Like after the dance because it'll be late. All right. What else on your homework? What else? 20. Oh. Extreme values and where they occur. I need a derivative. I need to find stationary points. Where's my stationary point? or my critical point. I got plus or minus square root of 2 over 3. I'm not going to worry about rationalizing a denominator. I'm not going to do all that crap here. What'd you say?
Did you give us less homework problems? These take forever.
All right. Really big negative, really big negative. If I plug that into the derivative, what happens? Is it positive or negative? Positive, because I'm look, this is my derivative. The derivative tells me what the function's doing. This is not even EVT. Yeah, so maybe like even negative 10. If I plugged in negative 10, because that's way smaller, right? Because this is not a closed interval. I'm not between things. This is from negative infinity to negative square root 2/3. Not really. Yes. In between a negative and a positive of the same value lies probably 0. Negative. And then a really, really big number, it doesn't matter because they're the same on either side, because when I square it, of course, is positive, which makes sense because this is a cubic and it will kind of look like that. Do you see how your sign analysis chart is kind of mimicking the graph here? It's like a little worm. This one is not on a closed interval now. It would, if it's a cubic like that, they would have to define that closed interval before they start. So it might not have an absolute max or an absolute min, but you can still, so you do, but the difference here is because it says find the extreme values and where they occur, you're finding the x and the y. Whenever we did it previously, we just found the x, but it's all semantic. Huh? Okay, that's not true. Yeah, these are just extreme values. All right. I don't have to find here because it's going like this. I'm not going to have any absolutes, so I don't have to worry about, come on, I don't know, my wrist tapped something. All right, but because it asked me for the values themselves, I do need to do this. I know where they occur, I just don't know what they are. And so, because I work smarter, not harder sometimes, if this is an FRQ, I would say that this is the max value, and I would leave it like that, at x equals negative root 2/3. But I'm not actually doing the work. You see what I'm doing? All right, so same thing I was doing before, right? Look. I didn't, do you see why it looks worse than what it is? I didn't actually find the value, right, Logan? I just replaced the X right there. I couldn't figure out where that was. I kept looking at Wyatt because it sounded like it was coming from Wyatt, but he's like staring at the board and at me, and you're tucked behind Sullivan's head, steady, like you haven't even taken a breath. You're talking so much, but it's low. Okay, Logan. I guess he's talking to Wyatt, but Wyatt's not even acknowledging the fact that he's talking. Wyatt's paying attention. Every time I've looked up, I've not seen Wyatt talking. I've just seen.
Oh, wow. You're just going to assume because I tend to talk a good amount.
Yes, that's a good assumption. It's a safe bet, Logan. You know what Max says? 99% of gamblers quit before they win big.
That's right, I wish.
All right. All right, give me other questions about your homework. 26 and 40, is that what you said?
Yeah, that's right.
That's not nice, Wyatt. Did that hurt your feelings?
Yes, you did. You know why he's on the boy, right?
Why?
You don't know why?
No. That's not racist. I say that all the time to everybody.
Say boy? To a black person?
To my son.
That's who your son is.
I can't see the board. Hey.
Logan, for goodness sake. All right. How do I find the derivative of this, Logan? That was not rhetorical. I said, how do you find the derivative of this, Logan?
Remove the exponent and then subtract one from the exponent and then you take it.
By the way,
Whoa. Yes, yes, it is. Hey, how about you don't worry about what's right now? How is it 1/3? Oh, because why? It would do the exponent and y to the exponent.
do I change this to an exponent so that I didn't have to do quotient? I don't need to know. Okay, which part didn't make sense? The way I took the derivative or the way I changed the form? I was going to say, give him a minute. He'll get it. What? I'm fixing to show you. All right, other questions about that thus far? Yeah. I agree. Shut your mouth. All right. Set it equal to 0, right? This is how I'm finding my stationary points. And this is where some of you got thrown off last week. Because when you look at this, you go, I don't know how to solve that. But you do know how to solve that because I've got 1, 2, 3 things multiplied together to give me 0. Zero product property says set each one of them to 0. Yes? Negative 1/3 is never going to be 0 no matter what I do, so it's not impacting my solution. Could 1 minus x squared to the negative 4/3 ever equal 0? Yes, maybe. We'll see. If I raise it both to negative 3/4, oh, that's actually undefined.
Bring me my money.
But I'm looking for undefined points as well, right? So, and the reason this is because 1 minus x squared to the 4/3 is in the bottom. Remember how we said for it to equal 0, the top has to equal 0. But if the bottom equals 0, that's also equally as important. Yes? Can I take the 4th root of 0? Yes, you can. It's 0. All right, so subtract 1, divide by negative 1, and take the square root. Now, how about negative 2x? Can it ever go to 0? Yes, if x is what? How many stationary points do I have? 3. Is this a closed interval or nah? Nah. Negative 1, 0, 1. Derivative, my f or y? Y tells me what the function's doing. Test the points in the derivative. Really big negative, positive or negative. Look at what I'm doing here. At the end of the day, this is in the bottom, but I'm raising to the 4th power. I'm raising to an even power. It's going to force that positive no matter what I put inside these parentheses. So the only thing that is determining my sign, that's right. So it's positive. So the sign of x determines the sign of my function, yes? Do we all agree? Do y'all see why? Sullivan, you with me?
It'd be negative because the negative times the really big negative on the giver is going to be a positive.
But look, negative times a negative gives me positive.
Yeah, but that's going to become a positive.
Right, so this,
Yeah, you're putting a negative in, so negative times a negative.
right, but you don't, what I'm saying is you don't even have to think that far into it. You can just say whatever the sign of x is the sign of the derivative. If x is negative, the derivative is going to be negative. If x is positive, we're into the bathroom or something. All right, so where are my extreme values occurring? It looks like I'm decreasing. I stop for just a minute. I keep decreasing, and then I start increasing, stop for just a minute, and start increasing again. So I only have one here, and that's occurring right here at 0. Is it a max or min? It's a min. So I have a minimum of, I don't know what f of 0 is. One over the cubed root of 1 minus 0 squared. We're going back to that original equation, which is just 1. Minimum of 1 at x equals 0. All that nasty work to come out with something like that.
Wait, hold on. No. Negative 1/3. That was not right. 1.
Cube root of 1 is 1. Or 1 to the 1/3 is 1. So the minimum is 0, 1. What did they get? That's right. 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 Right.
And then you multiply it by the 1 negative 1/3.
No, that's an exponent. The negative 1/3 is an exponent. That's in the derivative. We're back to the original function. Yep. All right. Anything else before we move on? Going once? 40. You didn't have to do that one.
Yeah, that was before you. 38.
All right. 38 was probably my favorite one on here. All right. Guys, y'all stay with me, because even if you understand it, Logan, you might be keeping someone else from understanding it. That's right. All right. All right, look, I'm going to find the derivative first. I have to do product rule here, yes? Derivative of the first times the second plus the first times derivative of the second, 1/2, 3 minus x to the negative 1/2 times negative 1. It is a pain. This is going to be minus, let me just set it up here, 2 square root 3 minus x. I think in order to find where this equals 0, we could either have a common denominator or set them equal and multiply across. I'm going to find a common denominator. I'm going to multiply by 2 times the square root of 3 minus x. So I've got 2x times 4 times 3 minus x minus x squared over 2 square root 3 minus x. Isn't this fun? Okay, so this gives you 8x times 3 minus, okay, where did what? Oh, I see. I did it twice. Sorry. Sorry. I got so excited. All right, so this gives me 12x minus 4x squared minus x squared over 2 root 3 minus x. Now the whole goal of this, remember, is where does it equal 0? Or undefined also counts, right? So I need the top and the bottom equal to 0. 12x minus 5x squared equals 0. 2 root 3 minus x. Bless you. You're right. And now this one, which is the doozy one. X equals 0 or x equals 12 over 5. That's Tony backwards. Shout out to Tony Shaheen many years ago. Do you remember him, Kenzie? You were little. He was in one of my classes, and he was such a cool kid. And he'd say, why not? And he'd say, that's Tony backwards. His name was Tony. Why not? Okay. It was actually, do y'all know Vincent Shaheen? He's been around Cam a long time. It's his son. His youngest son.
He spelled his name C-O-N-Y-W.
Like the letter Y.
Oh.
N-O-T. Why not? Okay. He also used to say I couldn't be a serial killer because I couldn't write a ransom note because they would know, like, sign it anonymously because they'd know who it was because I don't ever write anything the same. Like sometimes my 2s are like this, sometimes my 2s are like that, sometimes they're more round. I don't know. Anyway. Thank you. It kind of fell flat.
Why not?
That's Tony backwards. Okay. Derivative tells me what the function's doing. Let's find the signs here. Whoa! Okay, if I plug a negative into the derivative, I'm probably going to go with my cleaned up derivative here. So I can do so I can do the sign at the top and the sign at the bottom. So if I plug a negative up top, let's see, this is always going to be positive. Well, but it might impact my sign though. If it's negative,
That top could be positive. Because the negative, it doesn't really matter for the other side.
We're in negative right now.
Because that left, that right side could be negative always, but right side is going to be positive.
Let's say I have -1. -1 would be -12 minus 5 over, it's negative. Don't start that horse crap today. All right, what about if I plug in like let's say a 1? No, 12 minus 5 is positive 7. How about if I plug in like 2.5? I'm going to assume that's going negative. What happens if I plug in something bigger than 3? It's not in my domain. It's not in my domain.
The bottom has an imaginary.
No, it doesn't.
Yes, it does. 3 minus 4 is negative.
Wait, no, that was everything was one.
Negative. It's a negative. It's not my domain. All right, so there you go. I'm not going to waste time plugging this back in because I'm assuming this is the hardest. No, it stops at 3. Hush. The test. The test for concavity.
Oh, it's not having actual test.
Oh, no, that was first derivative test. We're going to do a second derivative test. I'm French. Wee wee. Okay. These theorems start to get jumbled up in your brain. So remember extreme value theorem. Closed interval, continuous on the closed interval means I have an absolute max and an absolute min. Yes? Have both. Say yes, because that's right. We have actually done mean value theorem, or I'm part of it. It hasn't formally been known as mean value theorem. I will say that they've said in more recent years, don't abbreviate theorems if you're referencing them. Like, don't say EVT. I know I do that frequently, so I'll have to get better about writing it out. Extreme value theorem. MVT is probably the most tested theorem. Mean value theorem is probably the most tested theorem, both on FRQ and multiple choice for whatever reason. But here's what it says. If your function is continuous, and differentiable, is every continuous function differentiable? Is every differentiable function continuous? Yes. So in order to be differentiable, it has to be continuous, but in order to be continuous, it does not have to be differentiable. Then, so if I'm continuous and differentiable on some closed interval, we'll say from A to B. Then, here's my if part. What does that mean? The derivative at C, or the slope of the tan line at C, right? Or another, how did we learn in the very, very beginning? What do we call it? Yes. AROC. Actually, this one is IROC. Getting ahead of myself with the second half of stuff. Equals, that's why you shouldn't write in pen. Were you huffing at me? What is that the formula for? Not definition of derivative. What is this? Think algebra 1. Yeah. Yeah. Slope. This is slope. This is just slope. It's AROC. You're exactly right. This says on some closed interval, right? I've got some function. It doesn't even matter what it does. If this is A and this is B, the slope between A and B, what kind of line is that called, by the way? I mean, yes and yes, but even more sophisticated. What'd you say? Secant. That's exactly right. Good job. So secant line. The slope of, did he tell you? The slope, golly. The slope of the secant line has to equal the slope of the tan line somewhere on there. In other words, there is a tan line that exists between those 2 points somewhere. Might not be right here, because right here, that's the tan line. Those slopes aren't the same. But somewhere in between these 2 points, there's at least one tan line that has that same slope. I'm thinking it looks like it's somewhere around, maybe right here. Maybe so, Miguel, maybe right here too. At least one though, right? At least one time, the average rate of change has to equal the instantaneous rate of change. That is all MVT says, yeah. Say again? secant line, it intersects the graph in two places. Normal line goes through the tan line at a 90-degree angle.
Don't really copy my shirt.
Y'all do have on the same shirt.
Yeah, she copied it.
Slope of the tan line equals slope of the secant line. Let's do an example. No. That's the whole one lesson. I'm gonna show you an example. Yeah. Well, y'all said I don't do hard enough examples. This is number 6. Let me write it a little bit darker. It's hot in here. I need $1 million.
Ha ha ha. That was a funny one.
Now he just does pocket things.
Does this function satisfy the mean value theorem? In other words, can we use the mean value theorem here? Why? What do I have to check for? Continuity. Is it continuous on its interval? That's what I'm checking for, right? Is it continuous on that closed interval? Okay, so how do I know it's continuous on that interval? What does the graph of log look like? It's an exponential on its side. Is it? He has.
Actually,
He's emailed me all his stuff before.
well, let's watch it.
That's where I get y'all's homework. He initially set that up. All right, is it differentiable on the closed interval? Yes. There's no cusp, corners, asymptotes, holes, nothing like that. So I'm good to go. So does it satisfy MVT? Yes. Find one place let me read it exactly the way it's written to you. They give you this, and they say, if it does, which it does, find each value of C in the interval AB that satisfies the equation.
All right.
So this is just plug in. That's exactly what it is. All I'm doing is finding a rock of the endpoints and setting it equal, right? Yep. All right, a rock of the endpoints. Let's do that first because that's the easiest. What is A, by the way? 2. What is B? 4. So f of 4 minus f of 2 over 4 minus 2. Right? What is f of 4? What was that original equation? ln x minus 1. So I've got log 3 minus log 1 over 2. What's the log of 1? 0, always 0. So on the right side of my equation where I plugged in, I've just got log 3 over 2. The question is, where does that equal f prime of c? I'm trying to find c. Well, what is f prime of c? What do I need to do? Take the derivative. Okay, where did I lose you? On the does it satisfy? Okay, so NVP takes, all I'm doing is slope of the endpoint. That's really all I'm doing. Y1 minus Y2 over X1 minus X2. Or Y2 minus Y1 over X2 minus X1. So my original equation was log of X minus 1, right? This is so aggravating. No. Hang tight. Let me work on the right side. All right. Are you with me, Addie? Do you understand what I was saying? So this is IROC. This is AROC. AROC is the same thing as slope. Slope between 2 points. What 2 points? Well, both endpoints. They didn't give me the y part of the endpoints. They only gave me the x part. So they gave me 2 as one of the endpoints. I had to find the other part of it. They gave me 4. I had to find the other part of it. Well, if this is my y, then if I plug in 2, I get log of 2 minus 1, which is log of 1. Right? What's y of 2? The log of 2 minus 1, which is log 1, which is, in other words, 0. If I plug in 4, y of 4 is log 4 minus 1, which is log 3. See where those came from now? Okay. All right, so all I did was slope to get this. This is AROC. Now back to that original equation, I need to show where does AROC equal what? IROC. So in order to do that, I need to find IROC. Yes? I rock, you rock, we rock. Okay. All right. So how do I find, remember, my function was natural log x minus 1. How do I find the derivative, f prime of x, of log x minus 1? 1 over x minus 1, and then chain it if I need to. Does this need a chain? It's just 1, so I don't need it, right? So if that's f prime of x, what's f prime of c? Come on, y'all can do this. Whatever's in parentheses, substitutes 1 over c minus 1. Because they gave me this formula in blue. This is what they gave me. And they said, show it. So I found f prime, and I replaced the x's with c's. That's all I did. So now, instead of f prime over here, it's 1 over c minus 1 equals log 3 over 2. Can you solve that? It's not quite as bad as it looks. Wyatt, I bet you know what to do. Wyatt's asleep! Yes, you're actually right. Well, because Wyatt always hollers butterfly, and this was a butterfly. All right. 2 equals, that's not what I said. Can you solve that for C?
Why? If you're not going to pay attention all 90 minutes of class, then just don't
All right. Now what? Devote. That's right, because log of 3 is just what? Devote, is that what I said? Oh my gosh. Devote both sides. Some days I feel like I'm just sitting up here and I feel like, yeah.
You feel like we're a lost cause.
No, not a lost cause. I just feel like y'all are sitting here going,
At this point, I am a lost.
like I'm just talking and it's just like going, like it might be hitting that wall and bouncing back to me for all I'm. No, I'm not calling you dumb. I'm just saying it's not. All right, and then add 1. Leave it like this, y'all. Don't try to do anything else with it. It's a constant. It's an irrational number. That's the answer.
Okay, yeah, you're gonna have to give us like 5 minutes.
All right, I got one more thing to tell you about. What did I say? It's easy. Why didn't? This is the C value where A rock equals I rock, which is what they asked me for. I think I'm gonna stop. We'll do antiderivatives Wednesday.
What is an anti-derivative? That sounds like a group that got together.
Well, if you've done derivatives, what do you think the antiderivative is?
Try and find your.
That's exactly right. If that's the, so instead of multiplying and subtracting 1, I'm going to divide and add 1. It's really easy. Do you know how? No, we won't be doing it with anything like that. We'll learn. That's what the whole back side of your green sheet's for. Yeah. Oh, I don't remember what it was now. All right, let's do this. Okay, so this is what you're working on in class tomorrow too. You got 90 minutes in class tomorrow to work on it because I won't be here tomorrow. So pace yourselves. Pace yourselves, okay? From days gone by. If you're gonna sing it, sing the whole thing or don't sing it at all, Sullivan.